Hi, today we're going to go over the build of an Eggtimer Quantum flight computer. This is a pretty cool flight computer. It's pretty much what I would consider my standard for dual deploy rockets. You can also use it as a dedicated air start computer if you want. It is Wi-Fi enabled, so you don't need an external switch. You can also use this with the telemetry module, which is really cool if you link that up with the LCD GPS. And then it's pretty small and economical, so I like it. This is my setup. I use a Hako FM203. You don't need anything this expensive at all, but it works really well if you're doing other projects. I use a 3mm iron at 680 degrees Fahrenheit. I do have my own spool of Kester 0.02-inch no clean solder wire, which is the same stuff that Chris sends you. And I use a silicone mat in a pan vise, which I highly recommend, as it is incredibly useful for a lot of things, not just soldering, especially in rocketry hobby. This is the package that you get from Chris. It's in a white envelope, just like most of the packages that you'll get from him. And all of the parts are in this anti-static bag. You get a checklist. And this is the part at the beginning where I highly recommend you do follow the checklist and inventory all your parts. It's not just to make sure that you have all your parts. I don't believe I've ever gotten a package from Chris that wasn't complete or that anything was ever missing. But more importantly, you want to identify each part and understand what they look like. And this is the best time to do it before you start soldering anything. Even if you've built these boards before, one, they do change, there are different revisions, and two, you can forget if you don't do these kind of things every single day. So I highly recommend doing this. Get your checklist out and actually checking it off. I do it every time, even though I've built a lot of these boards. This is the main board itself, the PCB that you're going to mount everything to. The next piece up is the Wi-Fi module. It's the larger chip with a lot of holes on the side. Next up, you have got a EEPROM chip. It's an 8-pin chip, and you should be able to see the 24C512 on it to identify it. The next thing up is a voltage regulator, and these are pretty standard through most of Chris's boards. So once you do it, you'll recognize these pretty quickly. This is a 3.3 voltage regulator, and it's the bigger. It's a chip with a bigger pin on one side and 3 small ones on the other. Then you get 2 driver chips. Those are also 8-pin. You get you got some parts that look very similar here. This is a MOSFET right now, and this one should say 13N06 on the side, and it looks very similar to these next 2 parts, which are rectifiers. And you want to make sure you don't mix these up. These rectifiers are pretty easy, one, because there's 2 of them that look exactly the same and have the same labels, and they say FERD on them, so look for that. Then you've got a really teeny little MOSFET here. It's got 3 small little pins. These kind of are they can be a little pain to mount, but we'll go through that later. You get 1 buzzer. Put that to the side. And then we're going to go through all these resistors. And when Chris says the white paper carrier, that's what he's talking about. And that first one was a 1K resistor marked 102. You get 2 of them, you only need 1. So he always gives you an extra one for these resistors. In this case, it's a 4.7K marked 472. You need 3, you get 4 of those. Then coming up next, you get a 10K set from 10K resistors marked 103. You need 4 of those, you get 5. Then up next is a 22K resistor marked 223. You need 1, you get 2. And finally, you get 100K resistors. These are marked 104. You need 2, you get 3. Now, this is where that white paper carrier comment comes into play again. It's the capacitors. Sometimes there's a lot of them. In this case, not that many. In the white paper carrier, you're going to get the 0.1 UF. You need 3 of those, you get 4. Now here is the clear plastic carrier. These are a little slightly different size. Very important, you only get 2 of these, you need 2, so don't lose those. Be careful, don't drop them, because they're very hard to find if you drop them on the floor. You do get some through-hole resistors. We're only going to need those to mount the Wi-Fi module. We'll go through that later. You get a right angle header, which will split up and put on various parts of the board. And then finally you get a terminal block, which is optional. And Chris does note in the instructions that he would recommend that you solder your, your lead straight to the board. I personally like the terminal block, and so I will install it in this build. This is the solder wire that Chris sends you. It's that no clean solder wire from Kester. Excellent stuff. Highly recommend it. But I have a spool of it, so I will not be using the stuff that Chris has. We're doing the Rev B1 version of this, which was new in 2022. So if there is a later version post this video, I will make a new video. But for now, we're going to do the newer V1 or B1 Rev, which is film is being made in November 2022. This is the most current version. I like to set up my board so it's nice and neat before I start soldering anything. This really, I think, is just as important as the inventory. Just getting all your parts in order, in place, makes it so much easier, and it's not a bunch of chaos when you're trying to find something that you're supposed to be soldering next. So while you don't have to do this necessarily, I do recommend a neat, clean soldering station while you're building these boards. As I noted, I use a pan device, highly recommended. It allows you to kind of flip the board around and put it in whatever orientation you want. You don't need one, but it's helpful. I use 2 pairs of tweezers, a flat pair and a pointy pair. Also very useful in getting these parts on where I need. And I cut the Wi-Fi number out and put it to the side so that you don't lose it. So the first thing that's up is, after inventorying the parts and setting up your board, is to orient your board so that the writing is kind of facing up. And then we're going to put in, the first thing we're going to mount is this the EEPROM chip. And it goes into this spot right here that I'm pointing to on the board, and you'll notice like there's a beveled edge and a dot. That has to line up with that little square. So make sure it does. And then we're going to tin one of the pads. I randomly picked that pad. And then you'll see me flip the board around a lot in the video, because one of the reasons I like the pan device is to be able to move the board around a lot. In this case, heat up the solder that you just tinned on the pad and then move the chip in place. Allow that to cool, and then check to make sure it's lined up properly. Once you're comfortable that it's all lined up properly, you go back through and solder all the rest of the pins. In this case, you don't want to really over solder it, but you want to make sure that you get some of that solder underneath the pad, underneath the pin and on the pad itself, and that there's enough to hold the whole thing in place. So you should have a nice shiny little bridge of solder on top of the pin when you're done. And then I do like to go back and re-solder that first pin, because there's not a lot of solder on top of the pin once you've done that. I will apologize, and I'll note in this video here that this portion of the video that occasionally the camera did focus in on my fingers instead of where I was actually soldering. I apologize for that. I will try to do this better in future videos that I make for these boards, for different kinds of Eggtimer boards, but you should have no problem figuring out what was done here, because this side is just like the other side, and once you're done it should look like this. Now this mark right here, I messed up the first time I did it, and I had to take the solder off with some soldering wick. You should note that that's not a bridge. It's just a black mark. It's just that in other places of the video it looks shiny, like I soldered between the hole and the pin. It is not. You should not have any solder between that pin and the hole. Absolutely none. And in this case, it's just a mark. So right here, you can see it actually looks like there's solder there, but there isn't. So moving on, the next thing you would mount is one of the 10K resistors marked 103, and it's right to the left of the EEPROM that you just put in place. And for these surface mounted parts, just tin one of the pads, move your piece into place, in this case a resistor. Make sure it's lined up properly. I like to use the soldering iron to kind of push the chip around, and then let go of it, let it cool so it stays in place. Solder the other side. Heat up that pad and the chip just a little bit. Get some solder in there. And once again, you don't have to over solder this, but get a nice little bridge over the chip to hold it in place and make sure the connection is good, and retouch up that other side, and you're good to go on that chip. Next thing up is these capacitors, and these can be confusing because there's some boards have a lot of these brown capacitors. In this case, these 0.1 UF capacitors are in the paper carrier. That's once again the white carriers that Chris will send the chips to you in. So make sure you've got the right ones. And in this case, I'm going to tin both of them, put them both on the board at the same time. Tin the pad, put it in place, turn the board. For me, again, this is one of the benefits of the Panavice, and then finish soldering that one, tin the other one, and continue on. Take a second here to reiterate the benefits of the Panavice here. It lifts your piece off the work surface, and it allows you to move it around. But also, as I noted, the Panavice is an excellent tool to have for all rocket building, especially if you're building low power and mid power rockets. Holding those parts in place and be able to work on them, very invaluable. I think it's a good investment. I think the silicon mat is another good investment over time. If you're soldering a lot, it's an excellent organizational piece, but you can solder right on it, which we will later, and you can see how some of the benefits you'll get when we do the Wi-Fi module. So once we finish these two capacitors, we'll move over to these small FET, the SI2302, and you can see those three small pads in a triangle right there, and that small chip fits in there. I'm going to tin the single pad and then move the chip in place. This one you definitely want to, it's slippery, it's small, get it lined up properly. Make sure the two, it's kind of hard to get those two single ones in the back lined up at the same time, so you might have to move it around a little bit, but once it's in, then just go ahead and solder all of the pins solidly. Once again, you don't have to use a huge amount of solder, but I like to use enough to make sure not only you have a good connection, but enough to make sure we're holding the chip in place. Next up, you've got a few of these 4.7K drivers or resistors, and they are all right in a row. And so that down at the bottom there, what I just pointed at, you can, if the solder happens to go over to bridge those pads to the oval pads, it's okay because they are attached. In this case, I will probably catch a little bit of heat for kind of going away from Chris's directions here of doing them one at a time, but since they're all right in a row, I like to line them up on the board and secure them all in on one side. And then turn the board and solder them all in nice and solidly. And again, apologize for uh, the camera focusing on my fingers rather than the soldering in this particular case. One of these days I'll have to go back and maybe reshoot these particular portions on another board and edit them in. But that's what it should look like when they're done. So then we have the two drivers. And these line up with a beveled edge as well. Against that beveled edge should be where those squares are, those small squares in the corner. So in this particular case, the writing kind of goes towards that where the 102 and 203 is. Now these have two large pads on one side that handle the two middle pins. So I like to tin that particularly large pad. Now these are kind of a pain in the neck to line up properly. The whole chip really wants to slide around. But once you've got it in place, I wouldn't mess with it too much. It definitely it can definitely move around on you, and it's a lot easier just once it's close. Personally, I just like to leave it there. So we'll move through this whole section, and now that you've got it tacked in there with the big pad, just go through and solder up all the other pins. Once you got that driver in, you just repeat the same with the other driver, and you're done with those. It should. So one of the things that's hard to see in this video is that you're not just lining it up properly. You got to apply a little downward pressure to make sure that the pins that you're trying to attach to the pad there don't just sit on top, right? You want them to actually be seated down there and not have any gaps underneath the two pins around it. So that can be part of the problem of why it wants to slip around a little bit, is that I am applying a little bit of downward pressure on the whole chip while I'm trying to line it up. Now, once you've got these two chips soldered in, this is a great time to go back and make sure you keep checking all of your solder joints with a 10x loop to make sure that they're, no bridges, solid connections, and nice shiny connections that would indicate a cold solder if they're not shiny. So install this 100K resistor on the board right next to the two drivers. And then the next thing we're going to do is put in this large voltage regulator. This is another one of those chips with a very large pad on one side, and that's the one I usually like to tin to hold the whole thing in place. This is another one of those kind of slippery chips that likes to move around on you as you're trying to hold it down. And also those outside pins on the other side have a tendency to they are tough to line up. There's not a lot of room to play. everything wants to move around. So get that. So in this case, I like to just hold it in place with the soldering iron for a second, then hold the whole thing down with my tweezers while it cools. Let that cool off really quick. And then in this case, you should be putting 30 seconds between each solder of the smaller pins. I'm going to skip forward the video between each solder joint so that you don't have to sit here for 30 seconds in between each one of these. But you should be waiting 30 seconds between each one of these solders to make sure that the chip doesn't overheat. And then once you get all of the small pins done, I definitely do like to go back and get a good chunk of solder onto the large pad. Part of this, as Chris notes in directions for many of these boards, not only to make sure it's tacked down properly and soldered properly, but this can act as a bit of a heat sink, a large chunk of solder on here for the chip itself. And then finally, on the bottom here, you are going to do the 1K and 22K resistors. They're right next to each other. So once again, probably not the preferred method of instructions in terms of you should do these one at a time. I like to just get them both on the board at the same time. Do make sure you're putting the right one in the right place. But these mount just like all the other resistors. Tin a pad. Tack them on. And then secure them to the board properly. All right, so now we've got the bottom of the board pretty much done, but do not do these two 103 10K resistors yet. Those are going to be done after we do the Wi-Fi module. So before we do the Wi-Fi module though, we're going to put a few parts on. First one we're going to put on is another one of these 100K resistors marked 104. Install that as you have the other ones. Another thing you're not really seeing in this video, because it's off to the side, is I clean the soldering tip after every time I solder a piece. And I use a brass wool and clean it thoroughly, and then go ahead and solder your next piece. If you don't do that, you lose heat transfer rapidly on the tip of your soldering iron. Okay, so now we're going to put in these 10 UF capacitors. These are the ones that came in the clear packaging. So you have to be real careful here because you don't get an extra one of these. Make sure you don't drop these on the floor. They are very hard to find if you do. And they're a little bit larger in size than the other capacitors you get. So make sure that you're using the right ones, but also note that they're a little bit harder to move around. They're kind of unwieldy on the board. And so this is a good spot to show, like, I did this and I put them in place, and then I took a good look at it and realized, wow, they're off just a little bit. So you can go back and move them around, right? Just heat up that pad again, move them back, move them to a better position, and then let that cool, and you're better off. You don't just proceed if they're in the wrong place. Go ahead and fix them before you move on. Now they feel much better lined up. I can go ahead and tack these on. Okay, with those 10 UF connectors done, there's another 10K resistor that goes into place. Install that one as normal. I think once you do one of these boards with the surface mounted chips too, personally I found that when I first started soldering these boards from Chris, that the Classic was easy because it had a lot of those through hole parts. But now I much prefer these surface mounted boards. It's so much faster than trying to put those through hole pins in, turn the board over, keep soldering. I find the surface mounted chip boards now go much faster. And once you kind of get the hang of once you do like 2 or 3 of these surface mounted parts, they become no problem. And then the last thing we're going to put on before we hit the Wi-Fi module is that last 0.1 UF connector. I'm sorry, capacitor. And once again, goes in the same way. Tack it onto a pad, make sure it's straight, and then secure it to the board. All right, with that done, the next step up is the Wi-Fi module, which can be a little intimidating, I get it. So I take I like to make sure my mat is clean. I wiped it down with isopropyl alcohol, and then you line up your through-hole resistors because you're going to need them all. Then I take a piece of tape, like Chris says, and they're about a 1/4 inch wide, give or take. I just cut it off a larger piece that I stick on the table. At least 3 inches, but it can be longer as long as you get that chip down and flat on the board. Now, here's why I like the silicone mat. Chris tries, in the instructions, there's a discussion of, trying to hold that pin straight, solder it while the board. The nice thing with the silicone mat, I just stick it right in the mat and get that first solder in, that first pin kind of tacked to the Wi-Fi module. And once that pin is in, it can be a little difficult to heat up that first pin. But you don't need a whole lot of solder here. There we go. Now, once it's tacked to the board itself, I like to then do the opposite corner personally. So cut this off about halfway with your clippers. It's not hugely important the amount you leave because there's more than enough wire, but by kind of sticking the pin in the mat on the first pin so it's solid, and then the second pin I put in the opposite corner stuck into the mat. Now once I solder this pin to that hole, the chip won't go anywhere. It's kind of functionally, stuck. The pins are stuck into the mat, and it gives the whole module kind of a opportunity to stay in place, even if you take the tape away. So from here on out, it's just as simple as putting each successive pin in, solder it to the, make sure they're kind of straight, solder it to the hole with just enough solder to hold everything. And I'm going to fast forward everything here, so it's going to kind of get a little wild. And then just cut off at the halfway point, clip off the actual capacitor, and then continue on that all the way around the board until you've got all 8 pins done. Apologies, it got a little, the focus went out on the side camera there for a little bit, but you get the idea from the split camera here that you're soldering them in all the way around until you have all 8 pins and all 8 holes soldered properly. Then take it off, the tape off, and inspect all of those joints. Kind of pry it out from the mat. Inspect all your joints. You should have kind of some long pins on the top of the board, but very long pins on the bottom, and they're all going to be a little bit uneven at this point. Just go through and even them all out, so that makes it a lot easier. I like to stick my finger over the clippers so the little pieces of pin don't go flying all over the place. And make sure when you're done with evening them out, you vacuum up all those little pieces of wire that are that are sitting on your work surface. You don't want those getting stuck on anything, or getting underneath the chip, or getting underneath the module or anything. They can definitely create, as Chris calls it, the vias underneath the boards. Once you've got them all relatively the same length, I personally find the tweezers to be the easiest way to go ahead and straighten them all out, relatively speaking. Make sure they're vertical in both directions, both to each other and to the chip itself. Just makes it a lot easier later on when we go to put this into the PCB. So at this point, I find the easiest thing to do is, before I clip the top, once again, go through real quick, make sure you vacuum up all of those little pieces of metal that are on the work surface. Put it back in your vise. I personally like to tape the chip down, but don't, as the instructions Chris gives you, do not force this module all the way down to the PCB. There should be about a 32nd of an inch between the PCB and the module. Once you have it where you want it and it's taped in place, go ahead and solder the first pin, make sure it's good, and then go through and solder all the rest of the pins around the board. Once again, we'll fast forward that a little bit to make it easy, but one thing you should note, yes, is to go to the opposite pin. Once I have the 2 opposite pins soldered in, you can take the tape off, because now the chip's not going anywhere. All right, so take the tape off and finish soldering all of the holes. And once again, you don't need a huge amount of solder on each one of these. You just want a nice little cone of solder, but don't forget, it's kind of going down through the hole and onto the bottom of the chip, the module. So you got to be careful you don't spread a bunch of solder underneath that hole and onto the bottom of the chip. Now go back through to the top and make sure that they're all those pins are nicely soldered and there's no gaps in there. I've found that out the hard way, that on one of these first ones that I made, that those really need to be soldered quite well. Now I like to go through and clip off the tops next. I like to use a pair of tweezers to cut them off. Once again, these little pieces of wire, they go flying, and not only can they get on your board and create a short somewhere, they can go right in your eye. Make sure you're wearing eye protection, and then do the same thing on the back. Clip them all off while holding that piece of wire so it doesn't go flying. Once you're done with that, you should have a nicely soldered Wi-Fi module on both sides. After that, there's not that many parts left. That we've got to go back and do those 2 10K 103 chips that we did not, resistors that we didn't put on the first time around on the bottom. So with your Wi-Fi module done, put those 2 chips in. Once they're tacked in, secure them to the board. Next thing up is the buzzer. In this case, make sure that you're orienting the buzzer correctly. The long pin is the positive, where the plus is, and there's also a plus sign on the side in a little circle there. So make sure that that long pin and the plus side line up to the proper hole on the board. Put that in place, and it might require you to kind of bend the pins a little bit back and forth to get it to fit into the holes. Once it's in there nice and secure, it doesn't have to be flat to the board, just enough to make sure those pins get through and it's flat. Once you're done with that, go ahead and snip off the ends of that buzzer. In this case, the pin was a little short, so I put my finger over that to keep that piece of metal from flying away. And there we go, buzzer's properly installed. And then we have these next pieces that look very similar. In this case, we start off with the MOSFET. It has a 13N06 on the label, so that's how you recognize it versus the other two, which are the same. And then when you're orienting it to the board, make sure you have that metal plate on the back of the MOSFET that lines up with that wide white line on the PCB. And that is the proper orientation for that piece. Make sure it is seated properly, and then tape it in place so it stays vertical and properly seated on the board and doesn't come back out. These are a little bit tough to kind of get right, mainly because when you turn it over, they want to kind of fall out. But get a good solder connection on here. These are large pins; they're a little bit tougher to heat up, but get them heated up properly and get a good solder base on these. All right, once you've got this MOSFET soldered in place properly, clip off the excess wire on the bottom, as flush to the board as you can, and once again, make sure you're careful of those small pieces of metal flying outwards. Next, the two pieces that look very similar to that MOSFET, these are the rectifiers, and you can identify them. They've got FD20 on the top, and once again you orient these so that that metal plate on the back of the rectifier is lined up against that white line on the board. I chose to tape these both at the same time. They can be a little rough to get right, to maintain vertical and keep them flush to the board. I like to get the tape to the sides and then kind of pinch it into my vise, and it keeps it tight. But if the tape goes over, just trim it before you get to those leads, and then go ahead and solder them in the same way. And we'll speed up the video a little bit here because it's pretty much the same as putting in the MOSFET. Once that's done, go ahead and clip those off flush to the board. Next up, we've got to get the terminal block on. Make sure that you orient the terminal block correctly. Those larger holes go to the outside. That's where you would put the wire in. Those are the ones that connect down. If you do it the wrong way, it still would work, but it's awful hard to get those wires into there. Tape it down and turn the board over and solder it in. You want to use a fairly good solder connection on these because the terminal block does kind of undergo a lot of stress, and the only thing holding it to the board are these little 4 solder connections. So make sure that you've got a really good connection here on your terminal block. Again, just reiterating, Chris does recommend you solder your leads directly to the board. With that done, we can put the angle header on, and there's 2 different places. One is a 3-hole connector and one is a single hole, so we have to snip off one of these angle head connectors. Hold on to that single piece for a second. Orient the angle heads so that they go over the Wi-Fi chip. Now you could put them to the outside. It's not going to change anything, and it's certainly not going to hurt it, but it does significantly increase the footprint of your board, which is not necessarily something you want to do. And those pins could kind of get caught on something and break off. So best thing to do is orient them over the Wi-Fi chip. Once they're taped in, solder them in place. Again, good solder connection here, because the only thing holding that angle head connector to the board are these solder points. Once you have those soldered in, put the single point in. It goes into the little 3v3 hole on the other side of the Wi-Fi chip. I do like to angle it ever so slightly away, less than what it's angled in this picture right now, but about right there. I like to angle it away from the buzzer a little bit, because if you put it too straight to the buzzer, I find it hard to get the connector on if you need to connect a wire to it. So slightly angled away, solder that in, and you should be fine. Well, with the angle head connector on, you're pretty much done with all the components. You do need some kind of battery connector. I'm using a standard female JST connector here because I'm going to be using 2S lipos for the logic on the board. So that familiar female JST connector is perfect. Do make sure you get the polarity right on the wires. As Chris notes, some of these kind of cheaper connectors you can get from offshore on Amazon or other places may have the polarity, the red and black wire switched. So test them when you get a package of them to make sure that they're oriented properly. Once you know the polarity of your connector is correct, red wire to the positive, black wire to the negative, and then solder those in properly. Now I am going to bridge the DP plus and the B plus connector or holes here, at least for testing. I don't know if I'll use a dual battery configuration down the road, but for now, in order to test it, we'll put a bridge wire in. This is just a piece of resistor wire from one of the 3-hole resistors. I just bend it over my tweezers, get a nice bend on that, a nice clean bend, and then just wedge it into the 2 holes so it doesn't go anywhere. You can tape this if you need to, but frankly, I just like to, if you put a little tension on it, it will stay in place. Turn it over, and I am not using a huge amount of solder here, just enough to make the connection, because if I do decide to go with a dual battery configuration down the road, it's kind of a pain to get all that solder out of there. So easier to just go light here for now, and then if I need to, I could always beef it up later. But clip those cleanly, and away we go. Now, first test, take the sticker off off the buzzer, and then we'll connect the battery to it, and we should hear a series of beeps. If we hear a series of beeps, then we are fairly confident we've done most of the work correctly. So, first test, here we go. Let's see if it works out first time go. Do make sure you get your battery cables connected properly. It is possible to shove that thing in the wrong way. Awesome. All right, so we got a first time go on that one. Now, we're going to connect it to Wi-Fi to make sure that works. On your device, look for the Quantum Wi-Fi SSID. click it, put in your password that came with the on the little piece of paper. Make sure you don't lose that little piece of paper. And if you've done your Wi-Fi module and all of your soldering correctly, it should connect nicely to the board. So once you hit connect, and using a Android phone, it has a tendency to tell me that a site can't be reached, or that it needs to be that I have to, acknowledge that it has no internet access. Hit yes, and then reload the page, and voila, it works. We have connectivity, and we can see that the board has no wires connected to it right now. The last thing I like to do here is actually write the password onto the Wi-Fi module itself. I have a tendency to lose these little pieces of paper, although I do also like to tape those pieces of paper to my my altimeter sled. But if you write it on the chip, it's the easiest way to make sure you don't lose it. And that is it. I'm not going to go over the wiring or mounting of this. We can do that in another video. This was just how to build the chip. I hope it works for you. Good luck.